Okay guys, welcome to WAM's Maths Academy. Today I'm going to be running through Northern Hemisphere 2017 Specialist Maths Exam 1. Okay, so answer all questions in the space provided, unless otherwise specified, use exact answers. In questions more than 1 mark, we've got to show working. Acceleration due to gravity is g meters a second, which is 9.8. Diagrams are not drawn to scale. Okay, so first one, 3-marker. A 5 kilogram mass on a smooth plane inclined at 30 degrees is held in equilibrium by horizontal force, magnitude p newtons, as shown in that diagram. On this diagram, show all other forces acting on the mass. Okay, so we've got our weight force, which you can either say is 5G or W. Either one will get you the marks. So we'll say 5G. And then we've got our normal force, which is perpendicular to the plane. Okay, find P. So the way I solve these, I would create a triangle here. I'm going to move this 5G to the other side, just to make it easier. So 5G. So I'm going to work out that component and this component here, and they have to be in equilibrium. So here, if that's 30 degrees, and I want to find out that component. So P cos, we know cos 30 is equal to that value. We'll call it x over P. So x equals P cos 30. So we can say P cos 30 minus a component going down the plane. That's 30 degrees, which means that's 60. And if we know that's 5G, we can say 5G cos of 60. That's going to give us this component going downwards. And together, they equal mass times acceleration. Because it's in equilibrium, it equals 0. It has 0 acceleration. Okay, so from here, what's cos of 30 and cos of 60? 60, 30, 1, 2, root 3. Cos of 30, P, root 3 on 2 is equal to, bring that to the other side. So you're going to get 5G cos of 60, which is 5G on 2. So therefore, P, they cancel, is equal to 5G on root 3, which is 5 root 3G on 3. You should rationalize, definitely in a special exam. Okay, fine. A, given that, when I integrate from there to there, it equals log E6, and it's between -2, and A is between -2 and 4. Doesn't necessarily mean that A has to be 4, but okay, I've got 8 on 16 minus x squared. When I derive that, I don't get that. It doesn't look like a tan question because there's not a plus in the middle. It's not sine or cos, so we're going to have to partial fraction it. So 8 on 4 minus x, 4 plus x, is A on 4 minus x plus B on 4 plus x. So 8 equals A 4 minus x plus B 4 plus x. If we let x equal 4, that's going to equal 0, so I'm going to get 8 equals 8b, so b equals 1. If I let x equal -4, I'm going to get 8 is equal to 8a, so a is equal to 1. So in this case here, we get the integral from -2 to a of 1 on 4 minus x plus 1 on 4 plus x. Okay, dx, and that equals log e of 6. So we're going to get, now, because I want the top here to be negative, because when I derive that I have to get a negative, then I have to put a negative at the front, so I'll get negative log e mod 4 minus x plus log e 4 plus x, and that is between -2 and a, and it equals log e 6. Okay, so let's bring it over here. So I've got log e, let's join them together. I'm going to have x plus 4 on 4 minus x, because remember that's negative, so when we divide, we can divide our logs. That equals a minus 2 log e 6. Okay, from here, when I sub a in, I'm going to get log e of a plus 4 on 4 minus a minus, when I sub 2 in, log e of -2 is going to give me 4 on 4 plus 2 is 6. So 4 on 6. That equals log e of 6. Okay, so from here, if I bring that to the other side, it's 2/3. And when I times the 6 by 2/3, I'm going to get log e4. And I get log e of a plus 4 on 4 minus a. So we can burn our logs. And then from here, a plus 4 is equal to 16 minus 4a. 5a is equal to 12. Have I buggered this up somewhere? So I've got a plus 4, 4 minus a, how did I get 4 up there? -2 plus 4 is 2. So that's a 2 on 6, which is 1/3. Bring it to the other side, plus 1 on 3. One on 3. So that's going to be a 2. Just like I don't remember getting this answer last year, which means that is going to be 8 minus 2a. So 3a is equal to 4, and a is equal to 4 on 3. That sounds better. Which is less than 4. So it seems pretty feasible that would be the correct answer. Yeah, so here, I don't know why, when I put -2 into that, I got 4, but it's -2 plus 4, which is 2. Okay, the gradient of the curve of that equation, when x equals a quarter, give your answer in the form a root b. Okay, so let's transpose it first. We're going to get y is 15 sine inverse of x. and then dy dx is, when we derive sine, it's just going to be 15 on root 1 minus x squared, gradient of the curve. So dy dx, given x equals 1/4, 15 on the square root of 1 minus 1 on 16, which is 15 on square root 15 on 16. But we can take that 16 outside, which would mean when you square root 16, you get 4/4. 15 divided by 1/4 is 60 on root 15, times it by root 15 on root 15. So that's going to give us 15. When we divide 15 into 60, we get 4 root 15. It's a nice easy one. Find the values of a and b, given that z minus 1 minus I is a factor. A and b are real. So if a and b are real, that must also be real. Z minus 1 minus I. Z minus 1 minus I. So that means its conjugate, Z minus 1 plus I, is a factor. From here, we know if we expand that out, we're going to get Z minus 1 squared minus I squared, which we know is Z squared minus 2Z, and then plus 1. And minus I squared is plus another one, which is Z squared minus 2Z plus 2. Now, if they're factors, then Z minus A times Z squared minus 2Z plus 2, we know that negative A times 2 has to equal negative 4. So we know negative 2A has to equal negative 4, so A has to equal 2. Is there any way that we could need another value? Okay, so if A was equal to 2, could we have any other values of A? So if A is equal to 2, it's going to be confusing, because it's going to confuse it with that Z and A. Okay, so if we want that to be negative 4, then this must be Z minus 2. So if we expand it out, we get Z cubed minus 2Z squared minus 2Z squared minus 4Z squared. And then we're going to have plus 4Z plus 2Z, which is plus 6Z, and then minus 4. So therefore, A plus B has to equal negative 4, and B squared minus A has to equal 6. From here, A is equal to minus 4 minus B. So here, I have B squared minus 4 minus B is equal to 6. B squared plus B plus 4, and then take away 6, is minus 2. So b minus 2, b plus 2, b minus 1. So therefore b is negative 2 or 1. Therefore a equals, let's just do them together. So therefore b equals negative 2 and b equals 1, and if b is negative 2, if I put that into there, then a is going to be negative 2. If b is 1, then a is going to equal negative 5. So I've got negative 2, or negative 5 and 1. Okay, for part of the graph, y equals root x plus 1 on the fourth root of 1 minus x squared. I wonder if you can do anything with that. So if you have x plus 1 on the fourth root of 1 minus x, 1 plus x, nothing simplifies there, does it? Because that's going to be to the power of a quarter. Not currently seeing anything you can do with it. Okay, find the volume generated of the region bounded by y and the lines x equals negative a half and a half when it's rotated. So negative a half, that's going to be rotated, and then that's going to be rotated, and that's our volume of our solid. Okay, so we know that's the integral from negative a half to a half of pi, so our volume is pi, y squared, so we're going to get x plus 1 on the square root of 1 minus x squared dx. Okay, so first thing I look at this thing here, we're going to have to split it apart because 1 on root 1 minus x squared, that's going to be sine inverse. And then I've got x on root 1 minus x squared. Okay, so let's go pi, negative a half to a half, x on square root 1 minus x squared plus pi, negative a half to a half, 1 on root 1 minus x squared dx. Now this one here, we're going to have to make a, I forgot the dx there. We're going to have to make a substitution because we've got x on root 1 minus x squared. So if we let u equal x squared, du dx is 2x. So we're going to have pi on 2, negative a half, but I'm not going to change those things. Okay, we've got to change the parameters because we're now substituting u. If I put a half into there to find out what u is, I'm going to get a half squared is a quarter. And if I put a half into that, I also get a quarter. So I'd be going from a quarter to a quarter. So that area is just going to equal 0. So we don't even need to do it. Scrap it. Because when we use that substitution, a half to a quarter to a quarter is just 0. Okay. So this thing here, this is pi sine inverse of x between a half and negative a half sine inverse of a half, it's got to be pi on 6. So I get pi on 6 minus sine inverse of negative a half. That's going to give us negative pi on 6, which, when I add them together, I get pi times, that's going to be plus 2 pi on 6, which is pi on 3, excuse me, which is pi squared on 3 units cubed. This is pretty annoying that it equals 0, because you could waste so much time doing it. Okay, find all real solutions of tan 2x equals negative tan x. We know that tan 2x is, what is it? It's 2 tan x on 1 minus tan squared x. So we can say 2 tan x on 1 minus tan squared x is equal to negative tan x. So 2 tan x is equal to tan cubed x minus tan x. Tan cubed x minus 3 tan x, because if I bring that to the other side, that equals 0. We can take out a tan x as a common factor. So we have tan squared x minus 3 equals 0. So we can say tan x equals 0. Tan squared x is equal to 3. Tan x equals plus or minus root 3. So if tan x equals 0, x is just n pi, n is an element of z. Here, if tan x equals root 3, 1, 2, root 3, it's got to be pi on 3, or 2 pi on 3, or we could just say plus or minus pi on 3. So x equals plus or minus pi on 3 plus n pi. N is an element of z. So therefore, x equals pi plus or minus pi on 3 plus n pi, or n pi. N is an element of z. So that's all of our solutions. I was just wondering if we needed to put the other solutions, but because we've got plus n pi, it's going to give you every solution around the circle. Okay, dy dx, express y in terms of x, where y naught equals that. Okay, so first thing we've got to do is flip it. So dx dy is equal to 1 on 4 minus y squared. So x is equal to the integral of 1 on 4 minus y squared dy. X is equal to 4 minus y to the negative 2 dy. So x is equal to, okay, add 1 to that. We've got to divide by it. So 1 on negative 1 times negative 1, which is 1. 4 minus y to the negative 1 plus c. So you get x is equal to 1 on 4 minus y plus c when x equals 0, y equals 3. So we get 0 equals 1 plus c. So c is negative 1. So we have x is equal to 1 on 4 minus y minus 1. So from here we get 4 minus y is equal to 1 on x plus 1. And then we get y is equal to 4 minus 1 on x plus 1. Okay, hopefully that's right. Alright, d squared y dx squared. So we know that dy dx is 4 minus y squared. I want to derive it again with respect to x. So I say d squared y dx squared is d dx of 4 minus y all squared, which using implicit diff is d dy of 4 minus y squared dy dx. If we diff this, we end up with negative 2 4 minus y, because 2 down to the front multiplied by the derivative of the bracket, which is negative 1, and then times dy dx, which is 4 minus y squared. So it's just negative 2 4 minus y cubed. So that's what d squared y dx squared is. How long have we got left? Okay, we're getting closer. Okay, a 3 kilogram mass has velocity of v equals 2 arctan root x when it has displacement x meters from the origin. Okay, so find the force. So we know force is mass times acceleration. So we need to find its acceleration. We know that acceleration is v dv dx. We know what v is, so we've got to find dv dx. So dv dx, now this is a chain rule question. So that's 2 tan inverse of x to the half. So if I derive that, it's probably easier just to actually so I get 1 on 2 root x. That's the derivative of that out the front, times 2, and then the inverse, the derivative of tan x is 1 on square root 1, not square root, 1 plus x squared. So here they're going to cancel. So I'm going to have dv dx is 1 on root x 1 plus x squared. So a is v dv dx. So it's 2 arctan of root x times root x 1 plus x squared. So therefore, our force is equal to 3 times that. So 6 arctan root x on root x 1 plus x squared. Is it x squared or just x with tan? When you drive tan inverse, sorry. Yeah, it's 1 on it, plus 1 on x squared. So, that looks pretty good to me. Okay, random variables this. Independent with u of x is that, so that's your mean of x. Your mean of y is 3. So my expected value of z is, so that's 2 times x, so my expected value of 2x plus my expected value of 3y. So that's going to be e of z is 2 times 4, which is 8, plus 3 times 3, which is 9. So it's going to be 17. My variance of z is going to be my variance of 2x, not zx, 2x plus my variance of 3y, which is 4 times my variance of x, plus 9 times my variance of y. Okay, 4 times 36 plus 9 times 25. 4 times 36 is 144, plus 9 times 25 is 225, which is 369. So therefore my standard deviation of z is the square root of that. 9 goes into that. 4, 41 times. So 3 root 41. Because 9 times 41 is equal to 369. And if we square root that, we're going to get 3 root 41. Okay, researchers have reason to believe that the mean of x has decreased. They collect a random sample, state the null hypothesis and the alternate. Okay, so null hypothesis. So h naught such that mu is equal to x. So that's going to be, what is x? 4. h1 is that mu is less than 4. So you've got to make sure that your notation is correct here. Okay, calculate the mean and standard deviation for a distribution of sample means x bar for samples of 64 observations. Okay, so e of x bar is the same as my population mean, and my standard deviation of x bar is my standard deviation, which is 6 because it's the square root of that, on the square root of the number in the sample, 64. So it's 6 on 8, which is 3/4. So e of x bar is 4. SD of x bar is 3/4. Okay, consider those vectors. Find the value of C if the angle between A and B is pi on 3. So we know A dot B is equal to the mod A mod B cos theta. So we can say cos theta, cos of pi on 3 is equal to A dot B, which is going to be negative 2 minus 2C plus 3 on mod A, so whatever the length of that is, 1 squared plus 3 at 2 squared is 5 plus 3 squared is 9, so it's root 14 times 2 squared, so 5 plus C squared, square rooted, okay, so what's cos of pi on 3? 1, 2, root 3, pi on 3, that's going to be a half. So I would get a half on this side, that's a half. So I'm going to cross multiply, so I'm going to get root 14, 5 plus C squared is equal to negative 2 plus that, that's going to be 1 minus 2C. So 2 times, because that 2 is going to go across, 1 minus 2C. So 14, actually let's expand it, it's 14 times 5, 50, 70, plus 14C squared is equal to, we've got to square this side. Now, we know that this has to be positive, so just remember that. So 2 minus 4C has to be greater than 0. So minus 4C has to be greater than minus 2. C has to be less than, if that's the case, C has to be less than 1/2. Because we know that's got to be positive, because if this is square rooted, it's got to be positive if it's real. Okay, so we've got 2 times 1 minus 4C plus 4C squared, which is 2 minus 8C plus 8C squared. So bring it all to the other side. So 6C squared, 70 plus 14C squared. So I've got 6C squared plus 8C, and then we've got to subtract 2, so 68. Is 0. Divide it all by 2, 3C squared plus 4C plus 34. Is that right? I forgot to square that, so that's 4. That's 4. Let's go back and fix it up. Yeah, so it's not 4 there, but it is once we square it. So 4 minus 16C plus 16C squared. So now bring all of this to the other side. So we get 2C squared minus 16C minus 66 equals 0. C squared minus 8C minus 33 equals 0. C minus 11, C plus 3 equals 0. Therefore, C equals 11 or negative 3. However, C has to be less than a half. Therefore, c is equal to -3. I know up here it says c is an element of all reals, but from here you can't solve, you can't have c being an imaginary number, which is what would be if the square root of something is negative. That squared shouldn't be there until we square the other side. Okay. Last question. If I remember correctly, this one was a bit of a bastard. Okay, so length of a curve parametrically is that's x, that's y. We know we've got to find dx d theta, because with a parametric equation it's the derivative of those two things squared, square rooted. So dx d theta is going to be a, derive sine we get cos, so minus a cos theta. Derive that, when we derive cos we get negative sine, so dy d theta is equal to a sine theta. Okay, so if we square it, dx d theta squared plus dy d theta squared is going to be a minus a cos theta squared plus a sine theta squared, which is a squared minus 2a squared cos squared theta plus a squared cos squared theta plus a squared sine squared theta. So these two things, that's just going to leave us with a squared. Oh, sorry, I shouldn't do that. So equals a squared minus 2a squared cos squared theta plus a squared cos squared theta plus sine squared theta, which is just 1. So I get 2a squared, 1 minus cos squared theta. Is that right? That's sine squared theta. 2a squared sine squared theta And then if I've got to square root that, I'll just get sine theta. I don't remember it being this easy. That's because that is not squared. I'm like, I knew there was something that's not right. See here, this isn't cos squared theta. That's just cos theta because it's just that, a times a. Okay, so we know that's just a squared. So we get 2a squared, 1 minus cos theta. Okay, so the a squared's okay because we can bring it out the front. So we'd say a from 2 pi and 3 to 2 pi. Okay, we've got 2, 1 minus cos theta square rooted. So somehow we're going to have to use a double angle formula, but we know that cos of theta is equal to, we've got to use a half angle formula. 1 minus 2 sine squared theta on 2. So if we sub that into there, we're going to get 1 minus 2 sine squared theta on 2. So that 1 minus that 1 cancels. That'll become plus 2 sine squared theta on 2. So it's going to be 4 sine squared theta on 2. And then square rooted, which is 2 sine theta on 2 d theta. So I can put that 2 out the front. So L is equal to 2a. Okay, so we get 2. Now if I integrate sine, cos when I derive it, I get negative sign. So it's going to be negative 2, because we've got to divide by a half, cos theta on 2 between 2 pi on 3. So I'm going to get 2, negative 2 cos 2 pi on that is going to be negative 1. So it's going to be pi minus 2 cos pi on 3. There's an a there as well, I think. Yeah, a. Okay, cos of pi is negative 1, so that's going to give me 2. And then here, cos of pi on 3 is a half, so that's going to be a half. Negative 2 times a half is negative 1, plus 1, so I'm going to get 2 plus 1, which is 3. So I get 2a times 3, which is 6a units. So that's how long the curve is from 2 pi and 3 to 2 pi of that function parametrically. 6a units. Don't give you much room. It's like you're a bloody genius and you can just work it all out in your head. Okay, so there is 2017 Exam 1 Northern Hemisphere. Hopefully I fixed up all the mistakes that I might have done as I went along. Just make sure they're all in the right form, so that's in the right form. A and B. So there's our 2 sets of solutions. It's my volume. General solutions, because it says, doesn't give us a domain. There's our function, y in terms of x, which is what it asked for. D squared y dx squared, so you've got to derive it again with respect to x and use the implicit diff. Here, you've got to remember dv dx is not your acceleration. dv dt is acceleration. V dv dx is acceleration. Yeah, so you've got to remember that when you're using your acceleration laws. They're all done correctly, I think. Don't forget, with special, you've always got to work out along the way when you can't have certain values. So here, when I square root something, I know that this value on this side has to be positive. So automatically I say, expand it out, 2 minus 4c has to be greater than 0, so c has to be less than a half, because that allows me to determine at the end whether or not I can have a negative or a positive value. If c was to equal 11, if we had 11 and put it up here, we would have negative 22 plus 1, so it's going to give you a negative value. So that angle couldn't possibly be pi on 3. Cos inverse of a negative has to be greater than 90 degrees. So that's another way you could work it out. And this one, you just got to make sure you don't stuff up anything along the way. Hopefully it helps. Yeah, not the easiest exams to go through, Spec, because they do have lots of annoying algebra, but hopefully you go well. Bye.